All right, here's the in-class activity we did. So each year, the U.S. Census Bureau provides income statistics for the United States. In the years from 1990 to 2005, they provided the data in the tables below. Okay, so we've got the tables there, and below them, we also have the graphs. So first thing, kind of looking here, question number 1. Okay. What is the estimate of the correlation coefficient for these data? So remember, when we're talking about the correlational coefficient, right, it's between 0 and -1 or 0 and 1, right? The closer you are to 1, the stronger it is. And at about 0.5, that's where, to the right, above 0.5, we consider that to be a strong correlation. Below is a weak correlation. Okay, same way, works the same way with the negative version, right? And this is a negative correlation, whereas here is a positive correlation. And then close to 0 or at 0 is definitely no correlation. Okay, so again, weak here, strong beyond. So if I'm looking at these, okay, I want you to try to guess first. So you should be trying these problems on your own first, and then just kind of watching this to see how well you did, okay? So just take a guess. Generally we go, to the 100th place in the decimal. So looking at this, they're pretty close together. So I'd probably guess, above a 0.5. Maybe for the men we do something like, 0.65. For the women, maybe it's a little bit stronger, I think, so maybe 0.75. All right? Then, number 2, we want to draw that line of best fit, okay? So we just take an estimate on these, and I'm going to just start right here, okay? And then just kind of estimate, and that line's probably a little too high. I'd probably actually like to be more like that. There's for men, for women, I'm going to start right here, and kind of go like that, okay? So, and how did I estimate my lines? I just, tried to average the points, kind of get right in the middle. Okay, so now let's take a look at number 4. So it says write the equation for each of the 2 lines, okay? So this is going to be 4A and 4B. I'm just going to do them right here. So I need my y-intercept, which looks like it's here in between 36,000, 38,000, probably 37,000. Okay, then I kind of have to estimate a slope. Looks like I have my point right there, and I hit that point right about there, which would be at 3. So my horizontal change is 3, and I go up 1,000. Or 10,000 actually. Nope, just 1,000. So it would be y equals 1,000 over 3. I'm not going to worry about reducing that. X plus 37,000. Okay, for the women's, we started at 18,000, right? So we have something, y equals something x. Okay, and again, it looks like I hit that point right there pretty good. So from 18,000 to that one, it's 14, so 14 on the bottom. And then I go up 2, 4, 6,000. So 6,000 over 14, which, probably could be reducing that, but I'm not going to be reducing it just for the sake of that. So that was 4A and 4B. Okay, now they want us with technology to figure out the actual correlational coefficient and the linear regression for each set of data. Okay, so let's jump over to the calculator and let's do that. To start off, we go new document. Okay, we're going to do lists and spreadsheets. Then we put our information in, right? We label it. And then looking at those tables, we start putting our data in. Okay. Then when we want to get to the graph, we'll do that. But I'm not going to spend the time now to do that. I already have them entered in. So if we take a look at this, you can see that I only needed to make one column for the year, and then also one for men and one for women, okay? And I went in a different order than it shows on the graph, but that's okay as well, okay? So let's find the correlational coefficient. So first I'm going to go Menu, Statistics, Stat Calculations. Let's do, sometimes it likes to do that. Let's do 2 variable statistics, hit enter. Okay, my list is year. Let's start with women. Okay, do women. Let's see, I have column A, B, and C, so let's put it in column D. Hit OK. Okay, then we scroll down and we find our correlational coefficient. So for women, we get that correlational coefficient of 0.96, right? Because we like to round. So there's that one. Now I can just continue from here, and I'll go back up. Just hit Menu again, Statistics, Stat Calculations. Now, because we're doing a linear regression, that's the line of best fit, I can actually use this to find the R value as well, okay? Works pretty similarly, okay? Again, I choose year. We'll choose men, okay? Go down. Let's choose column F. Hit OK. Now, notice this one actually gives me that linear equation. So it gives me my slope and gives me my y-intercept, okay? But it also gives me that correlational coefficient. So it gives me less information, so that's why sometimes I like to do that one as well. So 0.79 for men. Okay, now let's take a look at our graphs and let's do the calculator to find the line of best fit. So I hit Control Doc. I go down to Data and Statistics. Okay. And then we click to add variables. So I'm going to add the year here for the X. Then we can choose between men and women. So let's start with women. So there is our graph for our women. Okay, so to find the line of best fit, I go Menu, Analyze, Regression. Okay, because mathematically speaking, that line of best fit is a regression line. Okay, now there's a ton of different ones we can use, but we're going to use this linear one. Okay, and there's my line of best fit. Okay, my regression line, and we also have the line right there. Okay, so I'm going to hurry and take a screenshot of this to use later. All right, but so that gives us some of that information. Then if I just go to men, okay, see how it changes and gives me the information for the men as well. All right, so we've got that one that we can take a look at. So let's put these back on the other page and let's now answer those questions that go along with it. All right, so correlational coefficient for men was 0.79 and for women was 0.96. Okay, so we have a much higher, didn't do so great on ours, did we? We have a much higher correlation for women than for men. Okay, but they're both strong, they're still above 0.5. Okay, what does that tell us about how the data compares? Well, it tells us that the men aren't as in line as the women. The women are kind of going at a steady pace, about the same, keeping that almost to a perfect correlation, whereas the men, it's kind of changing from year to year and really thrown off, which we can tell when we look at those two different graphs, can't we? Okay, we can definitely see how much different that the men have, that part that goes up right here. Okay, so then we also have for men, we have their linear regression, 311.661 times x plus 37,629.7. Then for the women, we've got theirs, 464.1 times x plus 18,052.6. So slope, what does that mean? Well, slope, remember, that's the change in y over the change in x. The x stands for years. So the slope is telling us something about every year. The y change is our change in income. So that slope is telling us it's the change in income per year. Okay. Then what does the y-intercept mean in each case? Well, we started out in 1990. Number one was 1991. So in 1990, these were the median incomes that we had according to our line of best fit. Okay, now it may not be accurate, but without that data there, that's what it would end up being. Okay. All right, now we're going to take a look at these others. Okay, so that's the y-intercept was at 1990. So compare them. What do the lines tell the income between these years? Well, it tells us that men started out higher but are growing slower, whereas women started lower but are growing slightly faster. Okay. Now, what do you estimate will be the median income for men and women in 2015? And here's where the real power of these regression lines come from. Okay. So in 2015, which would be, right, this is 2010 is 15, so at 25 would be 2015, the way our numbering. So we're looking up and saying at what point, where would this line be at this point? And we use that regression line to help us. So what we do is we take these equations and we plug 25 in for x, and that's how we are going to figure it out. Okay? So for the men, we've got y equals 311.661x plus 37,629.7. So instead of x, though, I'm going to put in 25. Okay? And then all I'm going to do is I'm going to use the calculator to actually figure that out. So we put that in the calculator, and for men we get that in 2015 should be 45,421.2. Okay, for women we do the same thing, but with their different number of their equation. But again, I'm just going to put it into the calculator and let the calculator crunch all those numbers for me, which when we do, we end up getting 29,655.1. Okay? All right. So those are our estimates. Now, if we look at here on the second page, we can see that we've got from 2006 to 2011. Okay, the thing to notice here now is right here, things are going up, but between 2007 and 2008, things actually start to go down, don't they? Okay, that's going to throw off everything that we're dealing with right now. And if you think about it, you know, that was a time when some things happened that caused income to go down, and that's going to affect everybody. Okay, so we want to use technology to find the actual correlational coefficient and the linear regression for both, and then we're going to look at how that is going to affect these. So let's jump to the calculator again for this last part, and we'll add in that data. Okay, so we're back here now, and if we take a look here, we've actually went beyond and added in our new numbers. Okay, so now we have some more data here, but we want to find the correlational coefficients again, their linear regression, and then we're going to use that to estimate and talk about it. Okay, so first thing we want to do is let's get those correlational coefficients. So menu statistics, stat calculations. I can do either, because I'm doing linear regression, I can do that one, or two variable. Okay, this one again, we choose the year, we choose women first, go down here, let's be in D, so it's closer, hit OK, and we can go down and find our R. And we can also see our slope and our y-intercept. Okay, but now our correlational coefficient for women is 0.877, so 0.88. We'll round up. Okay, then we do it for men, hit menu, statistics, stat calculations. This time we'll do the 2 variable ones. So choose the year, choose men. Again, it doesn't matter which one we use. Just this one you have to go down farther. And we see that theirs is at 0.164, so 0.16. Okay, so that's going to change things quite a bit, huh? That makes that a lot lower. So now if we want to go graph it, we hit Control Doc, Data and Statistics, choose our year for X, we'll start with women for Y. Okay, we see our new graph, we hit Menu, Analyze, Regression, doing that linear, and we get that. Okay, then we hurry and take a screenshot of that to save for later. Alright, and we see our new regression line. Then we go to men, okay, and we see that one as well. Okay, now I'm going to skip ahead while we're on the calculator here. This line doesn't really look like a very good line of best fit, right? This is answering that very last question, number 13. Is a linear equation appropriate for these? Okay, and if I'm really looking at these, okay, I don't think they are the best ones for us, okay, because it's splitting the data. It's not looking at how that data is turning out to be, and it may go up, it may go down. Okay, we're not sure. But the cool thing is, if I go here to regressions, I can hide the linear. There's other options. Okay, we could try other functions we're used to, right? We could try an exponential. That one didn't look much better, did it? Okay, so hide the exponential, menu, analyze, regression. Let's try maybe a quadratic. Okay, if I look at that one actually seems to fit our data much better. But that's assuming that our data is going to keep going down. If not, if it goes up again, which most likely it will, okay, it's going to be not accurate again. So there's different options we can do. And if we did women, okay, again, that quadratic, that one looks really good for women, doesn't it? So there's other types of ways that we can do it, and linear isn't always the best. What if we did that exponential for this one? Okay, again, that one's not a very good one either, okay? But just some different things to look at here. So let's go back and finish this up. All right, so we got those to be, the men's was 0.16 and the women's 0.88. So the women's is still fairly strong, but the men's now, that correlational coefficient, that makes it pretty weak, okay? Which tells us that data is pretty spread out, okay? So then let's see what we got for our graphs and stuff. Okay, so again, we've got our equations, okay, for the women, for the men. Okay, 2015 was 25. Okay, so again, we can now take a look and compare how different our numbers are going to be, right? So for the men, we use the equation y equals 45.1182 times 25 plus 39,378.5. So notice how it changed both things. Okay, for the women, 300.758 times 25 plus 19,130.6. So it really changed everything, didn't it? Okay, the slopes were changed, the y-intercepts were changed, just everything was adjusted by having more data. Okay, so for men, we estimate 40,506.5 using this data, which was less than it was before, but maybe more accurate because of the way the numbers were trending. Okay, then we do it for the women, and we get, just again using the calculator to do that, we get 26,649.6, which was a little less than here, but not nearly as bad as for the men. Okay. So, and we kind of already talked about that last question, that it's not necessarily the most appropriate, and we kind of looked at some ways that it was or wasn't. Okay, but assuming that now that it's 2019, if we look things up, I'm sure things are going back up again, which is going to give it a completely different shape, and you'd have to find a completely different way to manage looking at that. All right, there we go, guys. That's what we did in class about this.